Welcome back to day 11 of our Deconstructing Industry Reality Check series. So today we're diving into the literal nervous system of our modern world, telecom. But, here's the core premise of today's explainer. Telecom, it's no longer just a passive pipe for your phone calls. It's actually waking up. It's starting to sense the world around us. We're moving from this history of static cables straight into a future of highly intelligent ecosystems. All right, let's just get right into it. Section 1, From Pigeons to Satellites, the Evolution of Connection. To really grasp this shift, we gotta look at how wildly fast things have escalated. I mean, think back to the 19th century. Early long-distance systems like the telegraph were absolutely revolutionary back then. Fast forward to the 20th century, and that brought us voice communication, early satellites, and mobile networks. That's really what turned telecom into this massive pillar of global commerce. But today is completely different. We aren't just sending signals back and forth anymore. We're building these incredible software-driven environments that are just deeply integrated into everything. I'm talking everything from your smart thermostat right up to entire city traffic grids. Moving on to Section 2, the AI-powered awakening, or as I like to think of it, when the network actually wakes up. We are in the middle of a really stark transition right now. Look, traditional telecom was super rigid, very manual, and completely heavy on hardware. You know the drill. If something broke, an actual human had to physically go out in a truck and fix it. But today's autonomous networks, they are the exact opposite. They're adaptive, heavily software-driven, and honestly incredibly intelligent. The network doesn't just sit there waiting for instructions anymore. It anticipates, it reacts, and it actually optimizes its own pathways on the fly. So you might be wondering, what exactly is AI doing behind the scenes here? Well, think of it like an ultra-fast, totally omniscient air traffic controller. These AI-powered systems are actively optimizing network traffic and managing these invisible radio spectrums way more efficiently than any human ever could. It's literally reducing congestion in real time. And for us, that means fewer dropped calls and absolutely zero lag when we're trying to stream something. You definitely don't see it happening, but it is the exact reason your digital life feels so totally seamless these days. Okay, Section 3. Erasing dead zones forever, expanding the reach. I really love this quote straight from our source material for this explainer. It says, from carrier pigeons to direct-to-cell satellites that kill dead zones forever. I mean, wow, that is an incredibly bold claim, right? But the crazy thing is, it's a reality we are witnessing right now. We are quite literally looking at the definitive end of the geographic dead zone. And here is exactly how that's happening. We're expanding access through satellite-enabled direct-to-device connectivity. Basically, this means we're no longer relying solely on, building these massive, wildly expensive cell towers out in the middle of nowhere. Instead, satellites in low Earth orbit are beaming access directly to the smartphone already sitting in your pocket. It's connecting remote and previously totally isolated populations straight from space. How cool is that? Now, back on the ground, we're also cutting the cord with fixed wireless broadband. This is huge because it completely bypasses the need to go out, dig up streets, and lay down expensive physical cable infrastructure to every single house. Instead of all that mess, it just beams high-speed internet directly to a receiver on your home. It's incredibly fast, super efficient, and it completely bridges the gap in areas where laying down traditional fixed-line infrastructure is just, too difficult. All right, Section 4, Beyond Basic Connectivity. Looking at platforms, not just pipes. The absolutely crucial point here is understanding how telecom is actually becoming a platform itself. And that's where edge computing enters the chat. In the past, data had to travel all the way to some centralized cloud, maybe hundreds of miles away, just to be processed. But edge computing, it processes data and AI applications right there, closer to the source, literally at the edge of the network. Think about things like self-driving cars or fully automated smart factories. They absolutely cannot afford even a single millisecond of lag. So the network itself now handles all that heavy AI processing instantly. It's a real game changer. And alongside the network, our devices are changing right along with it. Take eSIMs, for example. These advanced digital identity systems are completely replacing those tiny little physical cards. The ones you used to have to pop out with a paperclip. Well, by making identity purely digital, eSIMs are fundamentally reshaping how our devices connect. They make it completely seamless to switch carriers and exchange data with all these new smart platforms. So when you combine all these shifts we've talked about, the real-world impact is just massive. High-speed wireless broadband is truly democratizing access in places where physical lines simply can't go. And meanwhile, these enhanced wireless platforms, they're unlocking entirely new use cases. We're talking about next-level logistics, heavy industrial automation, and fully connected smart cities.
We're building environments powered by a network that actually senses and responds to its surroundings in real time.
Which brings us to Section 5, Opportunities and Massive Costs. Time for the reality check.
Okay, we've explored this amazing promised future, but we really have to take a hard look at the immense tension between these incredible advancements and, well, financial reality. Now, the opportunities are staggering, for sure. We get broader digital inclusion, way smarter infrastructure, and brand new service economies. But let's be real, the challenges are equally heavy. The sheer crushing cost of upgrading these networks is running into the hundreds of billions of dollars globally. That brings some massive investment pressures and raises very real questions about long-term business sustainability. At the end of the day, building the future is just incredibly expensive.
Which perfectly brings us to the final thesis from our source material today. Listen to this. Telecom is no longer only about connecting people to each other. Instead, it's increasingly about powering these intelligent, connected ecosystems across every single aspect of modern society. It has quite literally become the invisible nervous system that makes the entire future possible. And that leaves us with this massive foundational question to ponder as we wrap up. If telecom is powering all these intelligent ecosystems across our entire society, who is going to bear the ultimate cost of actually upgrading the world? Is it going to be us, the consumers, the big tech giants, or the telecom companies themselves? Thank you so much for joining me for this explainer. I really hope it helped clarify some of the massive shifts happening in the industry right now. Make sure you tune in tomorrow for day 12 of the series, where we're going to be deconstructing real estate and construction. See you then.